Hello everyone, welcome to Java tutorials. My name is Kishore. In this video, we will discuss about another type of typecasting which is done for derived data types, that is auto upcasting and explicit downcasting. Whenever we achieve runtime polymorphism, then auto upcasting is very much necessary. Only then you can achieve runtime polymorphism because you will assign different types of subclass objects to the superclass reference variable. By that, automatically the compiler is going to convert the subtypes to supertypes while assigning, and you will call the overrider methods to get that polymorphic behavior. To explain how this auto upcasting and explicit downcasting work, let me take one class like A and create one method called display method, and I print display in class A. Then I will create a class B that extends A. I will override the display method, but what I will do is I will create one more method here, void some get details of B, and I will print here get details of B is inside class B, and here we will change the class B, sorry, we will change the class A to class B, and then I will also write another class C that is going to extend B, and while overriding the display I will print display in class C, and we will keep this get details of B to get details of C, and we will simply print here get details of C inside class C. There is a purpose why I wrote the new methods in class B and new methods in class C, because whenever you achieve polymorphism, you usually create a reference of supertype. If you observe here, class A is the superclass and B is the subclass of A, and then C is the subclass of B. In that case, obviously, you can create a reference variable and you can assign different types of subclass objects. If I assign the object of C, if you observe here, the left hand side variable is higher type and the right hand side variable is lower type when you compare class C with the class A in an inheritance hierarchy. And whenever you are assigning lower type value to the higher type, usually what happens, Java compiler is going to automatically convert this type to A type. So from C to B, B to A. It is actually coming from bottom and reaching to top. That's why it is called as upcasting, and it is automatic. This is called as auto upcasting. The object of C will be automatically casted or automatically converted to the class A type. But what is the advantage of this? The advantage is you can use this same reference variable and take B object also. Here also you are assigning lower type to higher type. Auto upcasting happens here also. And the advantage is you can call the display method in both the case. And what is going to be the output? This display is same even in 29th line and 27th line. It is polymorphic in nature. If I run this program, I get different output. One is display in class C and another is display in class B because it is polymorphic. That is what the advantage we get by overriding. But why you need to explicitly downcast? Explicitly downcasting is nothing but you will convert higher type to lower type. When that scenario would occur is sometimes you may have the superclass reference, but that might be holding subclass objects and you want to access subclass members. Let's say now this A variable, though it is getting the B object, it cannot access the members of class B. So members of class B, if you want to access, what you can do, you cannot actually do like this. A dot get details of B means you do not get details of B. You need a reference variable of class B, and only then you can access the get details of B. In that case, what you can do, you can write B equals A because A is getting the B object and you are assigning the B object to B. But here you are assigning higher type to lower type. And whenever you are assigning higher type to lower type, you have to take care of explicitly converting the higher type to lower type. Java doesn't automatically do that. So how do you do that? You need to just write here B within the parentheses. Now the Java compiler will not give error because the reference of A is converted to the B type explicitly. This is called as explicit downcasting because you are coming from top to bottom and the conversion is happening from top to bottom explicitly. Now you can access the get details of B method because B is a type of class B. It can access all the members of class B. And if I run the program, I would see get details of B is inside class B. So, what is the purpose of downcasting means whenever a superclass reference is used in a polymorphism program, it can take all the subclass objects, but it can only call the methods present in the superclass or the overridden methods of subclass. It cannot call the members of the subclass. In that case, you need to convert the higher type to lower type by explicit downcasting. But there is one more problem when you do this conversion. What is that problem is, suppose you try to convert A to C type. This is going to not raise any error. Probably you want to call the members of class C. For that reason, you converted this A type to C type, thinking that it is going to work. At compilation time, there is no problem. This is you are assigning higher type to lower type, and it is explicit downcasting. However, you will get an error. Why you will get an error? Let's first see what is that error. If you see, it is printing get details of B, but you are getting an error called ClassCastException. And if I just scroll towards right side, it says B cannot be cast to C because A is having an object of B and you cannot convert B object to C type. But here you didn't get error because at this point of time, when you are assigning this A to B, what is happening is it is actually A is holding what object? B object. And obviously it is equals to B equals A, which equals to new B. But here what is happening is the C variable is getting A and A is actually still holding what object? B object. And practically writing like this is invalid because you are assigning the B object to C type. So that is actually not going to work at runtime. That's why the error what you get is class cast exception at runtime. So how do you take care of this is whenever you want to do an explicit downcasting, you have to take care of checking that A is holding the object of C or not. Here also you should check because this A can hold even A object type. In that case, if A variable is holding class A object, in that case also this is going to raise an error. Because A is holding B object, there was no error. So what you have to do is, whenever you are trying to do an explicit downcasting, you write this condition. If A variable is instance of B, only then you do the type conversion and call the members of subclass. Even here also you say if A is an instance of C, only then do the conversion. In that case, what happens? This code is going to check the A is actually holding an instance of B. If yes, it is going to do the conversion. And this condition is going to check if A is holding the instance of C. If yes, it will do the conversion. Else, it actually doesn't do the conversion because if condition will fail. So if I now run the program, I should see only get details of B is inside class B, but it is not invoking C dot get details of C because this if condition was not true. But here, let me assign A equals to new C once again, just to see whether we are going to get that output or not. If I run the program, now you can see get details of C is inside class C. So you have to be careful whenever you are doing an explicit downcasting because this superclass can take different types of subclasses, and when you are doing it downcasting, it has to be taken care by checking instance of that subtype or not. So what is the real-time example we can use from this is we have done one program while implementing method overriding, that is actually OTT program. What you can do is in one of the class try to create some new methods, maybe in basic plan or in standard plan. You try to create one of the method, and that method you try to access in the print benefits by using this a instance of C, what I am using here. Same way, when there is a print benefits which is taking the super class type, that is plan. So you can actually check this plan is a variable which is actually having basic plan, standard plan, or which is going to take even what is that, a premium plan also it can take. You can check is that plan instance of standard plan, then access the methods of standard plan. If the plan is instance of basic plan, access the methods of basic plan. That way you can actually make use of this downcasting. So just take that as an exercise and try to complete. If you ask where is that program, that is in this particular Java tutorial, that is called as Java tutorial 41, where we have implemented this method overriding concept with plan class, basic plan class, then standard plan class, premium plan class. Please use the extra methods in these classes and try to invoke those extra methods in print benefits by converting to standard plan or basic plan. So that is it about the typecasting for derived data types. See you in the next video. Thank you so much.